Tonight, we are going to dismantle one of the oldest and most comfortable images you have ever carried in your mind. You have held it since you were a child, lying on your back in the grass, looking up at the night sky. Stars. Bright, distant, scattered like grains of salt across an impossibly dark canvas, and between them nothing, a void, an empty stage on which a few distant lights happen to hang. That image is everywhere, in textbooks, on the back of every poster, in every illustration of space you have ever seen. And tonight, we are going to take that picture apart, piece by piece, because the truth of what fills the darkness between the stars is not just different from what you were taught. It is profoundly, staggeringly stranger. So here is a question, and it might be the kind of question that follows you into your sleep tonight. What if the darkness between the stars is not the absence of something, but the presence of something? What if that empty void you have imagined your whole life is, in truth, one of the most ancient, most chemically active, most strangely populated regions in the entire universe? Over the next 2 hours, we are going to travel into that darkness together. We will cross the very edge of our own solar system, to a place where 2 human spacecraft, launched before many of us were born, discovered a wall of plasma burning at 50,000 degrees, a thermal barrier no one fully expected to find. We will drift into clouds of gas so cold they are only a few degrees above absolute zero, and we will find that inside those clouds, the building blocks of life, the molecules that make up your body, are quietly, patiently assembling themselves in the dark. We will discover that our own solar system is not floating in typical interstellar space at all, but is instead sitting inside an enormous cavity carved out by the deaths of long-vanished stars. We will follow a hidden corridor of plasma, confirmed only in the last 2 years, that may connect us to other regions of the galaxy through a network no one knew existed. We will meet worlds with no suns. We will trace invisible forces that thread through every cubic centimeter of space, holding the galaxy together. And by the time we reach the end of this journey, you may come to understand that the atoms now in your fingertips, your breath, your bones, were once drifting in that very darkness, long before there was an Earth to hold them. Before we go any further, if you find this kind of deep exploration fascinating, a quick like or subscribe really helps the channel grow. It is a small thing for you, but it makes a huge difference for me. Now settle in, close your eyes if you would like. Let your breathing slow, and let us go together into the dark between the stars. Begin with the image you have always carried. You know this image. You have seen it 1,000 times in countless variations since you were old enough to understand what stars were. A black background. A few pinpricks of light scattered across it. That is space. That is the night sky. That is, you have been quietly told for most of your life, the universe between the stars. A perfect, untouched vacuum. An empty stage. The cleanest, simplest, emptiest thing imaginable. A pure nothing decorated occasionally by a star, a planet, a galaxy. It is a tidy picture. It is a comfortable picture. It is the picture every diagram in every science classroom has reinforced in your mind for decades. And it is wrong, not slightly wrong, not approximately wrong. Profoundly, fundamentally, breathtakingly wrong. Imagine for a moment that you are floating in deep space, halfway between 2 stars. There is no sun nearby. The nearest star is a faint pinpoint of light, light years away. You are surrounded by what your textbooks have always called the void. Now imagine that you could see, somehow, through different eyes, eyes that registered not just visible light, but every form of energy, every particle, every faint trace of matter. What you would see is something almost no one ever describes properly. You would see motion. You would see structure. You would see ancient, slow-moving currents of gas. You would see grains of cosmic dust drifting in their billions. You would see invisible threads of magnetic field looping across vast distances. You would see particles screaming through the darkness at nearly the speed of light. You would see molecules, real, complex organic molecules, quietly assembling themselves in the cold. And you would realize with a kind of slow shock that the void was never empty at all. It was simply too thin, too dark, too cold for human eyes to perceive. The first crack in the comfortable picture came over a century ago. It was the year 1904. A German astronomer named Johannes Hartmann was studying a star called Delta Orionis. You may know it better by its other name, Mintaka, the rightmost of the three stars that make up the famous belt of Orion. Mintaka, as Hartmann knew, is not a single star. It is a binary system, two stars orbiting one another. And because they orbit, their light should shift, ever so slightly, back and forth, as one star moves toward us and the other moves away. This is the Doppler effect, the same effect that changes the pitch of a passing ambulance siren. Hartmann was watching this dance in the absorption lines of Mintaka's spectrum, and almost all of them behaved exactly as they should. They shifted, they swayed, they breathed in and out with the orbit. But one line, a dark line caused by calcium absorbing a very specific wavelength of light, refused to move. It sat there, perfectly still, like a fingerprint pressed against a window, as if it were not part of the star at all. As if something else, something between the star and the telescope, were doing the absorbing. Let that sink in for a moment. In the early years of the 20th century, when most scientists still believed that space between the stars was a clean vacuum, one stubborn, motionless line in a spectrum quietly suggested otherwise. Something was out there, something invisible, something pervasive. Something that intercepted light across the staggering distance between Mintaka and Earth and left a fingerprint on every photon it passed through. That was the first whisper, the first crack in the comfortable picture. And from that whisper, over the following decades, an entire science would be born. By the 1910s and 1920s, the astronomer Edward Emerson Barnard had begun cataloging strange patches of sky, regions where the stars seemed to thin out or vanish altogether. These were not voids in the cosmic sense. They were opacity. Something was blocking the light. Barnard called them intervening opaque masses, and they would eventually be named dark nebulae. Then, in the 1940s and 1950s, the new science of radio astronomy began to reveal something even stranger. Vast clouds of neutral hydrogen, single atoms, each one of an unimaginably ancient origin, drifted across the entire galaxy, emitting a faint radio whisper at the wavelength of 21 centimeters. Ultraviolet observations later confirmed clouds of ionized gas, glowing softly in the darkness. Infrared observations uncovered dust. Each new instrument peeled back another layer of the so-called void and revealed it to be anything but empty. Slowly, painfully, generation by generation, astronomers gave this hidden ocean a name. They called it the interstellar medium, the ism, the matter that fills the space between the stars. And here is where the picture begins to truly transform. Because once you understand what the interstellar medium is, once you understand what is actually present in the so-called darkness, the universe stops looking like a few bright objects in a black sea and begins to look like an entire sea in which the bright objects are merely temporary condensations. Let us put some numbers to it. The interstellar medium in our own galaxy is composed of roughly 99% gas and 1% dust by mass. The gas is overwhelmingly hydrogen and helium, the two oldest elements, forged in the first 3 minutes after the Big Bang. The dust is something stranger, tiny solid grains of silicates, carbon, and ice, each one no larger than the smoke particle from a candle flame. And the density of all this material, it varies enormously. In the densest regions, you might find a few 100 million particles per cubic meter. In the thinnest regions, only a few hundred, sometimes fewer than 10. Now hold those numbers up against something familiar. The air you are breathing right now, at sea level, contains roughly 25 trillion particles per cubic meter. That is 2 followed by 25 zeros. So in the densest parts of the interstellar medium, the matter around you would be 100 billion times thinner than the air in your lungs. And in the thinnest parts, it would be 10 trillion times thinner than that. By every laboratory standard on Earth, this is still a vacuum, so thin that no vacuum pump ever built by human hands could artificially reproduce it. So thin that if you held out your hand for an hour in the typical interstellar medium, only a handful of atoms would drift through your fingers. And yet, the interstellar medium is not a vacuum at all, because the volumes involved are unimaginable. Picture this. Imagine you place a single grain of sand inside a cathedral. That is roughly the density of the densest molecular clouds in interstellar space. Now imagine that same grain of sand inside a cavern the size of the Empire State Building. That is the density of the diffuse regions. It feels like nothing. It is, by any reasonable definition, nothing. But now imagine you string these cathedrals and these caverns together, back to back, for 100,000 light years across the full diameter of our galaxy. Imagine the total number of grains of sand that adds up to. It is staggering. When you do that calculation honestly, you find something extraordinary. The interstellar medium in the Milky Way contains roughly 5 to 10 billion times the mass of our Sun. Roughly 10 to 15% of all the visible matter in our galaxy lives not inside stars, not inside planets, not inside the bright structures you can see, but in the so-called empty space between them. The darkness, in other words, is heavier than most of the visible universe inside our galaxy. Let that thought rest in your mind for a moment. The darkness is heavier than most of the visible universe. There is more to feel here. There is something deeply poetic, deeply almost intimate about what this means. Every photon of starlight that has ever reached your eye from the nearest star, from a faint galaxy at the edge of the observable universe, has crossed this ocean. Every twinkle in the night sky has been filtered, bent, scattered, absorbed, and shaped by the interstellar medium. The dust dims certain stars. The gas absorbs certain wavelengths. The medium itself becomes a kind of slow lens, a soft veil, through which every observation you have ever made of the cosmos has been performed. Think about that the next time you look up. The black between the stars is not the absence of the universe. It is, in many ways, the most pervasive, most patient, most ancient part of the universe, the part through which everything you see must always travel. And it is precisely because this medium is so thin, so cold, so dark, and so silent that no one ever notices it. For most of human history, we did not even suspect it existed. The Greeks did not. The medieval astronomers did not. Galileo, Kepler, Newton, none of them imagined that the space they were observing through was itself full of substance. It took until that one stubborn calcium line, refusing to move in the spectrum of Mintaka, for the secret to begin slipping into view. It is humbling, in a quiet way, to realize that the universe held this knowledge from us until 1904, and that we are still, even now, in the very early years of understanding what truly lives in the dark. So here is something I genuinely want you to share. When you used to look up at the night sky as a child, before you knew about any of this, what did you imagine was in the space between the stars? Did you picture nothing at all, just a pure empty blackness? Did you imagine some kind of mysterious substance, some kind of cosmic ether? Did you ever wonder if the darkness itself was alive in some way? Drop your honest answer in the comments. Tell me what your childhood mind invented to fill that void, because the truth, as we are about to discover, is stranger and more beautiful than almost anything most of us imagined. And the truth is also far from finished. Because knowing that the interstellar medium exists, knowing that the darkness is not empty, is only the first layer of the picture. What we have just described, This single phrase, the interstellar medium, is not actually one thing at all. It is not a uniform mist drifting evenly between the stars. It is not a single ocean of consistent temperature, consistent density, consistent behavior. It is something far stranger. The medium between the stars exists simultaneously in 5 distinct forms, 5 phases, 5 completely different environments layered through one another, ranging from temperatures so cold they are nearly absolute zero to temperatures hotter than the surface of the sun. They coexist. They mix at their edges. They flow into one another. And our own solar system at this very moment is moving through some of them in ways most people will never know. To understand what truly fills the darkness, we have to walk through each of these 5 worlds, one at a time. And we have to start with the coldest, oldest, quietest one of all. Begin at the coldest place. Imagine for a moment that you are drifting through a region of our galaxy far from any major star. Around you, the temperature is not the cold of a winter night. It is not the cold of the Antarctic. It is not even the cold of the upper atmosphere of Earth, where weather balloons freeze solid. It is something far deeper than that. The temperature around you is somewhere between 10 and 30 Kelvin, 10 degrees above absolute zero, 20 degrees above absolute zero. So cold that the molecules of nitrogen and oxygen that you breathe every day would freeze instantly into solid crystals. So cold that almost every chemical reaction you can imagine grinds to a near halt. So cold that the very atoms of hydrogen, which usually drift apart as a thin gas, begin to pair up into molecules, 2 atoms locked together as one, the simplest molecule in the universe, and the first sign that what you are drifting through is not merely empty space, but a vast cold place where matter is starting to clump. This is the first phase of the interstellar medium, the cold molecular clouds, the deepest, darkest, oldest parts of the ocean between the stars. You may already know some of these clouds by name, even if you have never thought of them as places. The Taurus molecular cloud, only 430 light-years from Earth, in the direction of the constellation Taurus the Bull. Inside it, a dense knot of gas called TMC-1, which we will return to in detail later, because it has become one of the most important laboratories of cosmic chemistry ever discovered. The Orion molecular cloud, 1,500 light-years away, glowing softly in the dust around the famous Orion Nebula, the same hazy patch you can sometimes see with the naked eye below the belt of Orion on a winter night. The Perseus molecular cloud, the Ophiuchus molecular cloud, the Rho-Ophiuchi cloud complex, the closest stellar nursery to Earth. These are not abstractions. These are real named places with real coordinates in the sky, where dense, freezing gas drifts through the dark, slowly knotting itself into the seeds of future stars. The cold molecular clouds are the most massive single component of the interstellar medium. A single one of them, like the giant molecular cloud known as Sagittarius B2 near the center of our galaxy, can contain 3 million solar masses of gas. 3 million suns worth of cold, dark matter drifting in a single cloud. They are the wombs of the galaxy. Every star you see in the night sky, every planet, every world that has ever existed, was once part of one of these cold, dense regions, including our own sun, including our own Earth, including somewhere in your atoms you. Now let us drift outward just a little away from the densest knots. The temperature climbs slightly. The molecules thin out. The hydrogen no longer pairs into H2. Instead, it drifts as single atoms, neutral, uncharged, but still cold, somewhere around 80 to 100 Kelvin. Still impossibly cold by Earth standards, but warmer than the molecular interior. This is the second phase, the cold neutral medium. Tendrils, sheets, and filaments of cold atomic hydrogen, weaving through the galaxy like a kind of structural fabric. If the molecular clouds are knots in the rope, The cold neutral medium is the rope itself, stretching between them. This is where some of the most beautiful imagery in modern astronomy comes from. When astronomers turn their telescopes to the cold neutral medium, they see filaments. Long, thread-like structures, sometimes tens of light years across, twisting and braiding through the galaxy. They are not random. They follow magnetic fields. They are sculpted by ancient stellar winds. They look, on the largest scales, almost like the structure of muscle fiber, or like the threads of a vast, invisible loom. The cold neutral medium is the architecture beneath the architecture. It is the framework on which all the bright structures of the galaxy hang, but keep drifting outward. The density falls. The temperature rises. By the time you have drifted only a few light years from the cold filaments, you find yourself in something altogether different. Around you, the temperature has climbed dramatically to somewhere around 6,000 Kelvin. That is roughly the temperature of the surface of the Sun. You are now floating in a tenuous warm gas of atomic hydrogen and helium, mixed with trace amounts of every heavier element forged inside dead stars. This is the third phase, the warm neutral medium. It is the bulk of the interstellar gas in terms of volume. Not by mass, the molecular clouds have far more mass concentrated into smaller regions, but by sheer volume, the warm neutral medium dominates. It fills the spaces between the cold filaments. It is the slow current of the cosmic ocean. And then, in certain regions, the gas begins to glow. The fourth phase reveals itself. Wherever there are hot young stars, massive blue and white stars, burning brightly with ultraviolet radiation, they strip the electrons off the hydrogen atoms in the surrounding gas. The hydrogen becomes ionized. It becomes a plasma. The temperature climbs to roughly 10,000 Kelvin, and the gas, lit from within by the captured energy of starlight, begins to glow softly in red. This is the warm ionized medium. This is what you are seeing when you look at images of the Orion Nebula, or the Eagle Nebula with its famous pillars of creation, or the Lagoon Nebula in Sagittarius. The vivid pink and red colors in those images are not artistic enhancement. They are the actual light of hydrogen plasma, glowing at the precise wavelength of 656 nanometers, the signature of an electron falling back into its place around a hydrogen nucleus. The warm ionized medium is the part of the interstellar medium you can actually see. It is the only part most people have ever knowingly looked at. But there is one more phase, and it is the strangest of them all. Drift away from the nebulae. Drift far from the bright young stars. Drift into the spaces between the clouds, the truly empty-feeling regions of the galaxy. And you would expect, perhaps, to find the coldest conditions of all out here, but you would be wrong. What you find instead in those great seemingly empty regions is plasma so hot that it defies intuition. Temperatures of 1,000,000 degrees, sometimes 10 million degrees, hotter than the surface of the Sun by a factor of 1,000. Hotter than the cores of all but the most massive stars. This is the fifth phase, the hot ionized medium, the scorching, almost invisible plasma that fills the largest volume of the interstellar medium in our galaxy. It is so thin that its density may be as low as 1 particle per 10,000 cubic centimeters, or less. You could pass your hand through a cubic meter of it and encounter only a few atoms in total. And yet, every one of those atoms is moving at speeds corresponding to millions of degrees, because temperature, on the atomic scale, is simply the speed of motion. The hot ionized medium is not hot the way a fire is hot. You could float in it for 1,000 years and not feel any warmth at all, because there is almost nothing there to transfer heat to you. But each individual particle, when you find one, is screaming through the dark at the speed of 1,000,000-degree plasma. Where does this scorching, almost ghostly substance come from? From the deaths of stars. From supernova explosions that, at the moment of their detonation, blast outward at thousands of kilometers per second, heating the gas around them to extraordinary temperatures, and then leaving it to slowly cool over millions of years. The hot ionized medium is, in a sense, the long, fading echo of every stellar death in the galaxy. Every time a massive star dies, it leaves behind a region of ultra-hot, ultra-thin plasma that persists for millennia, blending eventually into the larger network of hot gas that threads through the spaces between the clouds. Now hold this in your mind. 5 phases. 5 completely different environments, coexisting at the same time, throughout the same galaxy, sometimes within only a few light years of each other. Imagine a city in which one neighborhood is frozen at 30 degrees above absolute zero, the next is at room temperature. The next is at the surface temperature of the sun, and the next is at 1,000,000 degrees, and they are all next door to each other, blending at their edges, flowing into one another. That is the interstellar medium. That is what fills the darkness between the stars. Not nothing, not even one thing, 5 things. Layered, woven, breathing, exchanging matter and energy across boundaries we are only now beginning to understand. And here is something even more astonishing. Our own solar system, the place you live in right now, the system that contains the Earth beneath your feet, is not floating in any single one of these phases. It is, in fact, sitting at a very particular intersection of all of them. The solar system is enclosed in a kind of bubble of its own, created by the sun, called the heliosphere. The heliosphere is the vast region of space where the solar wind, the constant stream of charged particles flowing outward from the sun, pushes back against the surrounding interstellar medium. It is, in effect, a protective magnetic and plasma bubble, blown by our star, that holds the galaxy at arm's length. The heliosphere is enormous. It extends roughly 120 astronomical units from the sun, where 1 astronomical unit is the distance between the Earth and the sun. To put that in scale, if the orbit of the Earth around the sun were the size of a coin in your hand, the heliosphere would be roughly the size of a small house, with the planets clustered very close to the center, and the outer boundary the edge. Drifting somewhere out in the empty rooms, the boundary itself is called the heliopause, and it is, in a very literal sense, the shoreline of our solar system. Beyond it lies true interstellar space. For decades, the heliopause was a theoretical idea. No one had ever crossed it. No human eyes and no human instruments had ever been on the other side. And then in the late 1970s, NASA launched 2 spacecraft, Voyager 1 and Voyager 2. They were originally intended to study the outer planets, Jupiter, Saturn, Uranus, Neptune. They completed those missions, and then they kept going. They kept flying. Year after year, decade after decade, traveling outward at roughly 17 kilometers per second, slowly approaching the boundary of the solar system. And then on August 25, 2012, after 35 years of flight, Voyager 1 crossed the heliopause and entered the interstellar medium. It became the first human-made object in history to travel beyond our sun's protective bubble. 6 years later, on November 5, 2018, Voyager 2 crossed the boundary as well. And what they have been sending back ever since has been astonishing. Both spacecraft confirmed something that astronomers had long suspected. The plasma just inside the heliopause is hot and sparse. The plasma just outside is colder and denser. The interstellar medium in the immediate vicinity of our solar system contains about 40 times more particles per cubic centimeter than the bubble we live in. The transition, when each spacecraft crossed it, was abrupt, almost like a wall. A sudden change in particle density. A sudden change in the local magnetic field. A sudden silence in the kind of radio noise generated by the sun, and a new kind of background hum, a faint, persistent vibration that scientists now believe is the sound, if we can call it that, of the interstellar medium itself. oscillating at very long wavelengths. But it was even stranger than expected, because the temperature at the boundary region just outside the heliopause was not low at all. It was searing. Voyager's measurements suggested that the very local interstellar medium in the transition zone sits at temperatures somewhere between 30,000 and 50,000 Kelvin, 5 times hotter than the surface of the Sun. A thermal barrier, an invisible wall of fire so thin that the spacecraft passed through it without any damage at all, because there were too few particles to actually transfer heat. The energy was enormous. The density was almost nothing. And both spacecraft, still flying outward at this very moment, are now drifting through that strange, scorching, nearly empty environment, sending back data across light hours of distance, year after year, slowly running out of power but still talking to us from the other side. There is something deeply moving about this. The Voyager spacecraft were built with technology that, by today's standards, is laughably primitive. Their onboard computers have less processing power than a digital wristwatch. Their radio transmitters are dimmer than a refrigerator bulb. And yet, after nearly 50 years of flight, they are still doing science. They are still our eyes and ears in the interstellar medium. They are humanity's first ambassadors beyond the bubble of the Sun. And they will continue to drift outward, long after their instruments fall silent, long after Earth itself has changed beyond recognition, carrying their golden records of human music and human greetings into the deep ocean of stars, for as long as the universe lasts. What both Voyagers have shown us beyond any doubt is that the interstellar medium is real. It is structured. It is layered. It is dense in some places, thin in others. It contains plasma, neutral gas, dust, particles, fields. It has a temperature, a density, a magnetic structure. It is not the void of childhood diagrams. It is an environment. It is a place. And we are, for the very first time in history, beginning to feel its presence directly, through instruments that left Earth before many of us were born. Now think about that for a moment. Really sit with it. Voyager 1 launched on September 5, 1977. If you are in your 40s or 50s, your parents may have been young adults that day. If you are younger, you may not have existed at all. The spacecraft has been flying for almost half a century, and it has only just barely begun to escape into the true interstellar medium. It has not even reached the nearest star, not even close. The nearest star, Proxima Centauri, is about 4.24 light-years away. Voyager 1, traveling at 17 kilometers per second, would take roughly 73,000 years to reach a star at that distance, if it were aimed in that direction, which it is not. 73,000 years. Across what is, by cosmic standards, the very smallest of distances, the gap to our nearest neighbor. So here is the question I would like to leave you with before we move on. Voyager 1 has been traveling for nearly 50 years, and it has barely brushed the edge of true interstellar space. The nearest star is so far away that even at its tremendous speed, our most distant spacecraft would need tens of thousands of years to reach it. When you let that fact really settle into your mind, does it make you feel small in a way that is almost frightening? Or does it make you feel part of something so much larger and stranger than ordinary life? That the smallness becomes a kind of comfort. Tell me honestly in the comments. I genuinely want to know how that thought lands for you, because I think the way each of us feels about cosmic scale says something true about who we are. And there is still so much more to discover in the dark, because we have only just begun to map the contents of the interstellar medium. We know it has 5 phases. We know it ranges from nearly absolute zero to millions of degrees. We know it contains hydrogen and helium and dust and plasma. But hidden inside the coldest, darkest of those phases, inside the molecular clouds where the gas is thickest and the temperatures are lowest, is something no one expected to find. Something that for most of the 20th century was considered impossible. something that should not, by every rule of chemistry, be able to exist in such a cold, such a thin, such a violent environment. And yet it does exist, in vast quantities, in hundreds of varieties. Some of them are familiar substances you would recognize from your own kitchen. Some of them are molecules that, here on Earth, are considered essential to life. They are drifting in the dark between the stars, right now, assembling themselves patiently across millions of years. And to understand what they are, and why they matter so deeply, we have to step now into the strangest laboratory in the universe. Step now into the deepest cold of the molecular clouds. The temperature around you is somewhere between 10 and 30 Kelvin, only a few degrees above absolute zero. There is no light here. The nearest star is so distant that, if you look toward it, you would see only a faint, almost imperceptible pinprick of red, dimmed by intervening dust. There is no warmth. There is no obvious activity. By every rule of chemistry that you were taught in school, this should be one of the deadest, dullest, most chemically inert environments imaginable. Cold slows everything down. Cold halts reactions. Cold preserves things in stasis. The colder it gets, the less chemistry should happen. And yet, when astronomers first turned their radio telescopes to these clouds, beginning in the late 1960s and early 1970s, what they found was something so unexpected, so utterly contrary to the prevailing theories of the time, that for a while they did not believe their own data. They found chemistry, real, complex, organic chemistry, the kind of molecules that on Earth are associated with biology, with food, with industry, with the building blocks of life itself. Let us start with the simplest of them. In 1968, astronomers detected ammonia in the interstellar medium. The same ammonia you might find in a household cleaner, a molecule of one nitrogen atom bonded to 3 hydrogen atoms. The following year, they detected water, yes, ordinary water, as a gas in the cold, dark clouds between the stars. And then, almost immediately afterward, they detected formaldehyde, the same chemical used on Earth to preserve biological specimens, a molecule with carbon, hydrogen, and oxygen, 3 of the most important elements for life. That was only the beginning. Once astronomers knew where to look and how to look, the discoveries began to pour in. Methanol wood alcohol, hydrogen cyanide, carbon monoxide, methane, methylamine, acetic acid, the molecule that gives vinegar its sour taste. Ethanol, yes, the kind of alcohol in wine and beer, drifting freely in the cold, dark gas between the stars, in quantities that, if somehow collected and concentrated, would dwarf every distillery ever built by human hands. Glycolaldehyde, a simple sugar. Glycine has been hinted at, though not yet conclusively confirmed, in some clouds, the simplest of all amino acids, the building block of proteins. Acetone, ether, ethylene glycol, the molecule used in antifreeze. The list grew and grew and grew. To date, more than 260 distinct molecular species have been identified in the interstellar medium. 260. Not counting the isotopic variants, which would push the number far higher. Some of these molecules are familiar substances you have encountered in your own home. Some of them are so unstable that they cannot exist on Earth at all, because the warmth and pressure of our atmosphere would tear them apart. They exist only in the extreme cold and extreme thinness of the molecular clouds, drifting peacefully in the dark, where nothing disturbs them. Among the most extraordinary recent discoveries is a molecule called propargylamine. Astronomers detected it in 2020 in a vast cloud near the center of our galaxy, in a region known as the Central Molecular Zone. Propargylamine is what chemists call a prebiotic molecule. It contains a carbon-nitrogen double bond, the same chemical structure that is essential to the formation of amino acids, the building blocks of every protein in every cell of every living organism on Earth. Propargylamine is, in a very real sense, a piece of the long chemical chain that connects the simplest interstellar gases to the complex biology of life. And it was found drifting in the dark, not in some warm primordial pond, not on the surface of some hospitable planet, but in the freezing, lightless gas between the stars. In 2010, astronomers detected anthracene in a dense cloud near the star Cernus 52, roughly 700 light-years away in the direction of Perseus. Anthracene is a polycyclic aromatic hydrocarbon, a molecule made of 3 fused benzene rings. On Earth, polycyclic aromatic hydrocarbons are produced by combustion. They are found in soot, in cigarette smoke, in the residue of forest fires. And yet there, in a cold molecular cloud where no combustion is possible, anthracene exists in measurable quantities, drifting in the gas, patient and ancient. And then, in 2024, came one of the most extraordinary discoveries of the modern era. A team of researchers at the Center for Astrophysics, Harvard and Smithsonian, announced the detection of a molecule called 1-cyanopyrin in the same cold cloud, the Taurus Molecular Cloud, TMC1, that has become the most famous chemistry laboratory in the galaxy. 1-cyanopyrin is a large, ringed carbon molecule, far larger and more complex than anything most astrochemists believed could survive in the cold dark of interstellar space. The reigning theory had long held that such complex carbon molecules were created in the hot atmospheres of certain dying carbon stars, blown out into the interstellar medium, and then quickly destroyed by ultraviolet radiation, cosmic rays, and the harsh conditions of deep space. They were not supposed to last. They were not supposed to be common. They certainly were not supposed to be assembling themselves in the cold dark. And yet, there it was. 1-cyanopyrin, drifting in TMC1 in measurable abundance, defying everything astronomers thought they understood about interstellar chemistry. The implication was profound. It meant that the cold, dark clouds between the stars are not just storage vaults for molecules left over from dead stars. They are themselves active chemical factories, building complex carbon-bearing molecules from simpler ingredients, in conditions that should make such chemistry impossible. How does this happen? How can a region of space so cold, so thin, so dark, so seemingly inert possibly host such rich and complex chemistry? The answer turns out to be one of the most beautiful pieces of cosmic physics ever discovered. And it begins, of all places, on the surface of dust grains. Remember those tiny grains of interstellar dust we mentioned earlier, each one no larger than a particle of smoke from a candle flame. Silicate cores, carbon mantles, sometimes coated with thin layers of ice. They drift through the cold molecular clouds in their countless trillions. For most of the 20th century, astronomers thought of them as little more than obstacles to observation, annoying flecks of matter that absorbed and scattered the light of distant stars, making it harder to see what lay behind them. But over the past few decades, a different picture has emerged. The dust grains are not obstacles. The dust grains are catalysts. Imagine a single grain of interstellar dust drifting through a cold molecular cloud. Around it, gas atoms, hydrogen, oxygen, carbon, nitrogen, occasionally drift past. Most of them simply move on, but sometimes, by sheer chance, one of those atoms strikes the cold surface of the grain and sticks to it. The grain is so cold, just a few degrees above absolute zero, that the atom does not bounce off. It freezes onto the surface. It clings, and it waits. Eventually, another atom strikes the same grain and sticks. The two atoms, frozen onto the grain's surface, slowly migrate across it, drawn by faint quantum mechanical forces. And when they meet in the cold dark on the surface of that tiny grain, they bond. Two hydrogen atoms become one molecule of hydrogen. A hydrogen and an oxygen become a precursor to water. A carbon and a hydrogen become the seed of more complex carbon chemistry. The bond releases a tiny amount of energy, just enough to free the molecule from the grain, and it drifts off into the surrounding gas. This process is called grain surface chemistry, and it is, in many ways, the slowest, most patient form of chemistry in the universe. The reactions do not happen quickly. They happen over thousands, sometimes millions of years, but the clouds themselves are stable for millions of years. There is no rush. There is no clock. There is only the slow, gentle accumulation of molecules, one atom at a time, on the surfaces of countless tiny dust grains, across volumes of space larger than the imagination can hold. Across the entire Milky Way, hundreds of trillions of cubic light-years of cold molecular cloud are participating in this chemistry, simultaneously, in perfect silence, in perfect darkness, for ages upon ages. It is, in its own quiet way, the slowest and most enormous chemistry experiment that has ever existed in the universe. Now follow this chain of thought further. Because once the molecules have been assembled on the dust grains and released into the gas, they do not stay in the gas forever. Eventually, the cold molecular cloud begins to contract under its own gravity. The densest regions collapse inward. The gas piles up. The temperature begins to rise very slowly as the gas falls together. And at the heart of the collapse, a new star begins to form. Around that new star, a disk of leftover gas and dust forms a protoplanetary disk. Within that disk, the dust grains begin to stick together, growing first into pebbles, then into rocks, then into boulders, then into planets. And carried along, embedded in all of that material, are the molecules that were assembled in the cold dark. The water, the formaldehyde, the methanol, the amino acid precursors, the complex carbon rings. They are not destroyed by the formation of the new star. Some of them survive. Many of them are incorporated into comets, into asteroids, into the icy outer worlds of the new planetary system. And eventually, billions of years later, some of those comets and asteroids may collide with a young rocky planet, delivering their cargo of cold-assembled molecules to the surface of a world that has just become warm enough, just become wet enough, for chemistry to begin again. This is not speculation. This is the leading scientific picture of how our own Earth acquired much of its water and much of its organic chemistry. Samples returned from asteroids in the last few years, from the asteroid Ryugu, sampled by Japan's Hayabusa 2 mission, and from the asteroid Bennu, sampled by NASA's OSIRIS-Rx mission, have been found to contain organic molecules of extraordinary complexity. Amino acids, nucleobases, the chemical letters of life's alphabet. Molecules that were not synthesized on Earth at all, but were carried here, ancient and ready from a much older time, when our own solar system was still part of a cold molecular cloud. Let that sink in. The molecules in your body, the carbon in your cells, the water in your blood, the nitrogen in your DNA. A meaningful fraction of those atoms were once drifting in the cold dark between the stars, frozen onto the surfaces of dust grains, slowly assembling themselves into more complex forms, for ages before our sun was even born. They survived the birth of the solar system. They survived the formation of the Earth. They survived the cooling of the planet, the formation of the oceans, the long, slow chemistry that gave rise to the first cells, and they are still here. They are in you, right now, as you listen to this voice. You are, in a very literal and very physical sense, made out of the interstellar medium. There is something deeply humbling about this, and something quietly, almost unbearably beautiful. The darkness between the stars is not just the place from which the stars emerge. It is the place from which we emerge. Our bodies are constructed out of the slow, patient chemistry of the cold dark. Every breath you take is filled with atoms that, at some point in their long history, drifted through interstellar space, frozen onto a dust grain, took part in a reaction that lasted longer than human civilization, and were eventually woven into a planet, a plant, a cell, a person. There is one more layer to this, and it is perhaps the most extraordinary of all, because the chemistry is not just happening in cold molecular clouds inside our own galaxy. In recent years, astronomers using the James Webb Space Telescope have detected complex organic molecules in galaxies that lie more than 12 billion light-years away. These are galaxies whose light has been traveling toward us since less than 2 billion years after the Big Bang, when the universe was still very young, when the heavy elements had only just begun to be forged in the first generations of stars. And even then, even in those ancient times, the cold dark between the early stars was already brewing organic chemistry, already weaving the precursors of life, already preparing, in some sense, for the kind of complexity that we ourselves represent. The implications are staggering. If the chemistry of life is happening, even quietly, in the cold dark between the stars across the entire universe, and has been happening since not long after the universe itself began, then the building blocks of biology are not rare. They are not special. They are not a unique gift bestowed upon one particular world. They are common. They are everywhere. They are drifting in the dark between every star, in every galaxy, throughout the entire observable cosmos. Whether those building blocks ever assemble themselves into actual living organisms on actual worlds in other places besides Earth, that, of course, is another question. And it is a question we cannot yet answer. But the raw materials are present. The chemistry is real. The dark between the stars is not just empty space, and it is not just thin gas, and it is not just dust. It is also a vast, slow, patient, universe-spanning preparation of the molecules from which life can be made. So here is something I want you to genuinely consider, and to share with me if you feel moved to. The same molecules that on Earth are considered the building blocks of life, the amino acid precursors, the carbon ring structures, the simple sugars, the prebiotic chemistry, are assembling themselves right now in the cold dark between the stars, not on a planet, not under a sun, just drifting in the gas on the surfaces of tiny dust grains in conditions of cold and darkness that we would call deadly. Does that change how you think about whether life elsewhere is possible? Does it make the universe feel more crowded with potential? Or does it make Earth feel even more precious as the one place we know for certain where this chemistry actually took the next step? I genuinely want to know how that thought sits with you, because it sits differently with different people, and the honest answers I have heard from listeners have been some of the most beautiful conversations I have ever had. And there is still more to discover. Because everything we have just talked about, the 5 phases, the molecular clouds, the chemistry, the dust grain factories, has been happening in what we have called, casually, typical interstellar space, the interstellar medium of the galaxy in general. And there is a quiet, almost embarrassing assumption hidden inside that phrase, the assumption that we, ourselves, are surrounded by typical interstellar space, that our sun, drifting through the galaxy, sits in a perfectly average region of the medium, like a fish in an average patch of ocean. But that, it turns out, is not true at all. Our solar system is sitting in one of the most unusual addresses in the entire Milky Way. We are not in typical interstellar space. We are inside something extraordinary. A structure that astronomers in the last few decades, and especially in the last 2 years, have only just begun to map in detail. A structure carved out by the deaths of ancient stars, shaped by forces from millions of years ago, and connected, we now believe, to a much larger hidden architecture spanning the galaxy itself. To understand where we truly are, you have to begin somewhere unexpected. Not with our solar system itself, but with the deaths of stars we will never see. Roughly 14 million years ago, in what was then a relatively crowded region of the Milky Way's spiral arm, a small association of massive young stars began to die. Not one star, not two. A whole succession of them. Stars perhaps 20, 30, 50 times the mass of our own sun. The kind of stars that burn so brightly and so fiercely that they exhaust their nuclear fuel in only a few million years, and then collapse, and then detonate in the most violent events in the universe outside of a black hole merger or the Big Bang itself. Supernovae. Stellar explosions so bright that, for a few weeks, a single one of them can outshine the entire galaxy that contains it. These supernovae did not happen all at once. They happened in sequence, spread across millions of years. Each one threw its outer layers outward at thousands of kilometers per second, blasting the surrounding interstellar medium with enormous shock waves of hot gas. Each shock wave swept up the gas around it, compressing it into a thin shell at its leading edge, and leaving behind a hot, evacuated cavity in its wake. And as one supernova after another exploded in the same region, each new shock wave expanded into the cavity left behind by the previous one, finding less and less material to slow it down, and pushing the boundaries of the cavity further and further outward. Over the course of those 14 million years, the cumulative effect of these stellar deaths carved out a vast, roughly spherical hole in the interstellar medium of our galaxy. A region nearly empty by interstellar standards. A region filled with hot, ultra-thin plasma at temperatures of around 1,000,000 Kelvin. A region whose outer wall is made of the swept-up gas and dust that the supernovae shoved aside as they expanded. That region is the local bubble, and our solar system, at this very moment, is sitting almost exactly in the middle of it. The local bubble is roughly 300 light-years across in some directions, and as much as 1,000 light-years across in others. It is shaped a little like an irregular peanut or a bipolar nebula, with two lobes extending above and below the plane of the galaxy. It is far larger than the distance to most of the stars you can see with your naked eye on a clear night. If you look up at the night sky tonight and pick almost any of the brighter, closer stars, Sirius, Procyon, Altair, the stars of Orion's belt, the Pleiades, many of them lie within or near the boundary of the local bubble. They are not just our neighbors. They are our roommates. We are all sharing the same hot, empty cavern in space, carved out by the deaths of stars we will never meet, in a long-vanished cluster whose surviving members are now scattered across the galaxy. Let that picture rebuild itself in your mind. Our solar system is not floating in typical interstellar space. We are floating inside a bubble carved by ancient supernovae. We are surrounded, in every direction, by the remnants of dead stars. The hot, thin plasma that fills the local bubble is itself the long, fading echo of those stellar deaths, gas heated to 1,000,000 degrees by shock waves that swept through here long before there were any humans to feel them. How do we know this? How could anyone possibly map something so vast, so thin, so invisible? The first hints came in the late 1960s, when astronomers noticed something odd about the way starlight is dimmed by interstellar dust. As light from a distant star travels toward us, it passes through the interstellar medium, and the dust along the way scatters and absorbs some of that light, making the star appear slightly redder and slightly dimmer than it actually is. Astronomers call this effect interstellar reddening, and they had assumed, reasonably enough, that it should increase smoothly with distance. The further away a star is, the more dust the light has to pass through, the more reddened it should appear. But in the late 60s, the astronomer M.P. Fitzgerald and others noticed that, within roughly 100 parsecs of the Sun, about 325 light-years, the reddening was almost absent. Nearby stars were not being dimmed nearly as much as the theory predicted. It was as if the dust around us had been swept clean, leaving a hollowed-out region of unusually transparent space. The implication was clear, even if it sounded almost too strange to believe. Our solar system was sitting inside a hole in the interstellar dust. Over the following decades, the picture sharpened. X-ray observations revealed that the cavity was filled with hot plasma, glowing faintly in the soft X-ray background. Ultraviolet observations of nearby stars showed weak absorption from interstellar gas, confirming that the cavity was also sparse in cool material. Mapping the boundaries of the cavity took years of patient work, and the maps are still being refined today. But the conclusion has been inescapable for some time. The local bubble is real, it is enormous, and we are inside it. In January 2022, a research team led by astronomers at the Center for Astrophysics, Harvard and Smithsonian, published a paper in the journal Nature that turned this entire story into something far more profound. Using detailed three-dimensional maps of nearby star formation, they traced the positions and motions of every young star and every nearby molecular cloud back through time, like running a film in reverse. And what they found was extraordinary. The young stars in our vicinity, the stars of the Taurus molecular cloud, the Pleiades cluster, the Ophiuchus star-forming region, the Lupus and Chameleon complexes, are all sitting on the surface of the expanding shell of the local bubble. They are not random. They are not scattered. They are pinned, like beads on a sphere, to the outer wall of the cavity carved by the ancient supernovae. And when the team traced their motions backward in time, they found that the molecular clouds from which those stars were born did not exist in their current positions millions of years ago. Instead, the expanding shock waves of the original supernovae, sweeping outward through the interstellar medium, had compressed the gas they encountered into a thick, dense shell at the leading edge of the bubble. That compressed shell of gas eventually became dense enough to collapse under its own gravity, fragmenting into molecular clouds, which then collapsed further into individual stars and planetary systems. In other words, the deaths of the original massive stars did not just create the local bubble. They created our nearest neighbors. Every young star within a few hundred light years of us, every nearby stellar nursery, every newborn world drifting through the local arm of the galaxy owes its existence to the deaths of the stars that came before. This is one of those discoveries that changes the way the night sky feels, because it means that the bright stars and the glowing nebulae around us are not just unrelated objects scattered randomly through nearby space. They are members of a single story. They are the descendants, the children, of the stellar deaths that hollowed out the local bubble. They formed because of those deaths. They sit today on the slowly expanding edge of the cavity left behind. And we, our sun, our Earth, you and I, are sitting in the geometric heart of that story, looking outward at the consequences of an ancient violence we will never witness directly. There is something almost mythic about this. The cosmos, in many cultures and many traditions, has always been understood as a place of cycles. Birth and death, creation and destruction. Stars are born from clouds, and clouds are born from the deaths of stars. The local bubble is, in its own quiet way, one of the most direct, most physically detailed examples of that cycle ever discovered. The death of stars in one generation is not the end. It is the literal, physical preparation of the next generation. The supernovae that carved out the local bubble 14 million years ago are still today, building stars on the edge of the cavity they created. There is more, because in October 2024, another extraordinary discovery was added to the picture. A research team based at the Max Planck Institute for Extraterrestrial Physics, using data from the EROSITA X-ray telescope aboard the Spectrum Röntgen Gamma mission, published a detailed new map of the local bubble, or as they prefer to call it, the local hot bubble, to emphasize the searing temperature of its interior plasma. EROSITA, orbiting at a stable gravitational point in space called L2, about 1 million miles beyond Earth, had been scanning the entire sky in soft X-ray wavelengths for several years. By assembling the data into a high-resolution map, the team was able to see the structure of the local bubble in unprecedented detail. What they found was something theorists had predicted in the 1970s, but no one had ever conclusively confirmed: a tunnel. A narrow corridor of hot, low-density plasma extending outward from the local bubble in the direction of the constellation Centaurus. Not a random thinning of the bubble's wall, not an irregular bulge. A coherent, elongated, tunnel-like structure running through the surrounding denser interstellar medium, connecting our local cavern to other regions of the galaxy. In December 2025, follow-up analysis of the same data revealed additional tunnel-like structures, including another one pointing toward the constellation Canis Major. These narrow plasma corridors appear to act as low-density pathways, connecting the bubble we live in to other cavities elsewhere in the galaxy. They are, in essence, the first direct confirmation of a hypothesis that has been quietly waiting in the scientific literature for 50 years. That the interstellar medium of our galaxy is not a smooth, uniform sea dotted with isolated bubbles. It is, instead, a vast, interconnected network of bubbles and tunnels. A frothy, sponge-like architecture in which the hot, thin cavities carved by supernovae are linked to one another through narrow corridors of equally hot, equally thin plasma, threading through the denser gas and dust like the channels of an enormous galactic foam. Think about what this means. The local bubble is not just a cavity. It is one node in a network. There are other bubbles out there. There are other cavities carved by other supernovae in other regions of the galaxy, and they are connected. They are connected through these tunnels. The interstellar medium of the Milky Way is not a continent. It is an archipelago. The bright, denser regions where the gas and dust pile up are the islands. The hot, empty bubbles are the lagoons. And the tunnels are the straits and channels that link one lagoon to another, weaving through the structure of the galaxy in ways that astronomers are only just beginning to map. If you imagine the galaxy as a forest, you might once have pictured it as a relatively even canopy of trees, with stars scattered throughout. After the discoveries of the local bubble and the EROSITA tunnels, the picture is different. The galaxy is a forest in which ancient fires have burned vast clearings. Some of those clearings are the size of small towns. Others are larger than entire cities. And cutting through the dense woods between the clearings are narrow paths of scorched earth, where smaller blazes once raced from one cavity to another. We live in one of those clearings, and we are now beginning to see the paths that lead away from it. There is something both humbling and exhilarating about this. Humbling, because it means our address in the galaxy is far stranger than we ever imagined. Exhilarating, because it means there is a vast architecture waiting to be explored, a hidden topology of the interstellar medium that we are only now learning how to map, and the mapping is accelerating. Because in 2025, a new mission joined the long tradition of probing the boundary between our solar system and the interstellar medium beyond. NASA's Interstellar Mapping and Acceleration Probe, IMAP, was launched and now resides at the same L1 gravitational point that the famous SOHO mission has occupied for decades. IMAP is designed to study the very boundary of the heliosphere, the protective bubble of solar wind that the sun blows around our planets, in unprecedented detail. It will measure the particles streaming inward from interstellar space, map the structure of the heliopause, and trace the ways in which the medium around our solar system is shaped by both the sun's wind and the surrounding interstellar conditions. Lead researchers on the mission have described IMAP as a much more advanced successor to NASA's earlier IBEX mission, which spent more than a full 11-year solar cycle gathering data on the boundary of the heliosphere. IMAP will do the same kind of work, but with far greater resolution, far greater sensitivity, and the ability to detect features that IBEX could only hint at. Together with the still-flying Voyagers, with the long history of ground-based observations of nearby stars, with the X-ray maps from EROSITA, and with the painstaking three-dimensional reconstructions of nearby molecular clouds, IMAP is part of a quiet revolution in our understanding of the interstellar environment around us. Year by year, the map is sharpening. The bubble is becoming clearer. The tunnels are coming into view. And the larger architecture of the galaxy, the foam, the network, the hidden topology, is slowly beginning to take shape on the maps of the people who study it. We are, in some sense, alive at a remarkable moment. For most of human history, no one even knew the interstellar medium existed. For most of the 20th century, no one knew the local bubble existed. As recently as 2 decades ago, no one knew that the supernovae which carved the bubble also triggered the births of every nearby young star. As recently as 2024, no one had ever confirmed that interstellar tunnels link our local cavity to other parts of the galaxy. The picture has been transforming so quickly that the textbooks have not yet caught up. The version of the night sky that most people carry in their heads, even most well-educated people, is a generation or more out of date. You, listening to this voice tonight, now know something about your home in the galaxy that most of humanity has never heard. You live inside a bubble carved by ancient stellar deaths. The stars nearest to you were born from those same deaths, on the expanding shell of the bubble's edge. There are narrow corridors of hot plasma connecting your bubble to others, threading through the galaxy like the unseen circulatory system of a vast, slow body. And human spacecraft, still flying, are mapping this environment from the inside, in real time, sending the data back to a small planet on the third orbit around an unremarkable star, near the geometric center of a cavity older than human civilization. There is something almost overwhelming about this picture. It is the kind of fact that, when it lands properly, rearranges the way the night sky feels. Because once you know that the supernovae which carved your home in the galaxy were the same supernovae that built your nearest neighbors, you can no longer cleanly separate destruction from creation. They are the same act, viewed across different timescales. The same violence that ended one generation of stars seeded the next. The same explosions that hollowed out the cavern around us also pressed the gas into the molecular clouds that gave rise to the Pleiades, to Taurus, to Ophiuchus, to every newborn world drifting in our part of the galaxy. And that question lingers. It lingers in a way that touches everything else. Because if the cycle of stellar death and birth is, at the largest scales, what creates the conditions for new stars and possibly new life, then destruction in the cosmos is not the opposite of creation. It is its method. The two are inseparable. The night sky is a record of both at once. So here is something I would genuinely like you to share. When you let this picture settle in your mind, that we live inside a cavity carved by the deaths of massive stars, and that those same deaths were what allowed our nearest neighboring stars to be born, does it change the way you feel about destruction itself? Not just stellar destruction, but the larger pattern, the ways that endings make beginnings possible, the ways that loss on long enough timescales prepares the ground for something new. Does that thought sit easily with you, or does it unsettle you? Tell me in the comments. I want to know how the realization lands when you stop to truly feel it, because I think it changes people in different ways. And the honesty of what each of you carries away from this picture is part of what makes these conversations meaningful. And there is still more to explore, because the architecture of bubbles and tunnels we have just walked through is the architecture of ordinary matter, the structure made of gas and dust and plasma, the part of the interstellar medium that we can map by detecting its light, its X-rays, its radio waves. But threading through every cubic centimeter of all of it, through the cold molecular clouds, through the warm filaments, through the hot ionized cavities, through the tunnels, through the bubble walls, through the boundary of the heliosphere itself, is something else. something that does not glow, something that does not absorb light, something that does not show up on any X-ray map or radio image. Forces and particles and structures that are, in many ways, the most pervasive and most powerful components of the interstellar medium, and yet are almost completely invisible to direct observation. And to truly understand what fills the darkness between the stars, we have to step now into the realm of what cannot be seen. There are forces and structures in the dark between the stars that you cannot see, cannot hear, cannot touch, and cannot easily imagine. They do not glow, they do not absorb light, they do not announce themselves with any obvious signature, and yet they shape, in ways large and small, almost everything we have discussed so far. Begin with the magnetic field. The interstellar magnetic field is so weak that, by the standards of any laboratory on Earth, it would barely register at all. A typical strength of only a few microgauss, roughly 100,000 times weaker than the magnetic field of the Earth itself. If you held a compass in the middle of the interstellar medium, the needle would barely twitch. By any human standard of magnetism, it is almost nothing, and yet it is everywhere. It threads through every region of the galaxy. It loops and bends across hundreds of light years. It follows the spiral arms. It dives through molecular clouds. It bends around bubbles. It threads through the tunnels we just described. The total volume occupied by the interstellar magnetic field is incomprehensibly vast. And although it is weak at any given point, the sheer scale of its presence makes it one of the most influential forces in the galaxy. Consider what it does. The dust grains in the interstellar medium are not perfectly spherical. They are elongated, slightly irregular, often shaped a little like tiny rice grains. And because they are made of materials that respond to magnetism, they tend to align themselves with the local magnetic field as they drift through space. They are not yanked into alignment violently. They are simply, over long stretches of time, gently nudged into orientations that follow the magnetic lines. When astronomers measure the polarization of starlight passing through clouds of dust, they can map the orientations of those aligned grains. And when they do, they see something extraordinary. The grains across vast volumes of interstellar space all line up with each other, like iron filings around the lines of a much larger magnet. The magnetic field of the galaxy is invisible, but its fingerprint, written in the alignment of countless trillions of dust grains, is everywhere. The magnetic field does more than orient dust. It shapes the way molecular clouds collapse to form stars. It channels the flow of charged particles. It guides cosmic rays through the galaxy. It even helps regulate the rate at which new stars are born, by either supporting clouds against gravitational collapse or, in other configurations, allowing them to fall together. In 2025, a major new computer simulation of magnetism and turbulence in the interstellar medium revealed that, on small scales, it is chaotic turbulence rather than ordered magnetism that ultimately governs how the densest knots of gas form into the seeds of stellar clusters. But on larger scales, the magnetic field is a kind of slow conductor, organizing the flow of matter across the galaxy in ways we are still working to understand. Then there are the cosmic rays. The name is a relic of an earlier era of physics, when no one was quite sure what these mysterious signals from the sky actually were. We now know that cosmic rays are not rays at all. They are particles. Individual subatomic particles, mostly protons, with some heavier atomic nuclei and a smaller number of electrons, accelerated to extraordinary energies by some of the most violent events in the universe. Supernovae, the shock waves of supernova remnants, the magnetic environments around neutron stars and pulsars, the jets of active galactic nuclei, the collisions of massive structures across the cosmic web. Every one of these processes can take an ordinary atomic nucleus and whip it up to speeds approaching the speed of light, sending it screaming outward into the interstellar medium. Once accelerated, cosmic rays travel through the magnetic field of the galaxy, looping and curving along its lines, eventually filling almost every region of interstellar space. They pass through the cold molecular clouds. They drift through the warm and hot phases. They pour through our solar system. They rain down on the Earth constantly, day and night, year after year. At sea level, several muons of particles produced by cosmic ray collisions in the upper atmosphere pass through your body every second. As you listen to this voice, individual particles, accelerated by stellar explosions you will never see, are quietly passing through your bones, your blood, your brain. They have been doing so all of your life. They will continue doing so all of the lives of everyone who follows you. The energies involved in some cosmic rays are difficult to grasp. In 1991, a single cosmic ray particle was detected over the deserts of Utah by an experiment called the fly's eye. The particle was given the informal name the "Oh my God" particle, because the energy of that single subatomic particle was so far beyond anything else ever recorded that the physicists who measured it could scarcely believe their own instruments. The "Oh my God" particle carried an energy of roughly 3 times 10 to the 20th electron volts. To translate that into something you can almost feel, that single proton, smaller than an atom, carried the kinetic energy of a baseball thrown at about 90 kilometers per hour. A baseball, compressed into a single proton, hurtling through the interstellar medium at almost exactly the speed of light, until it slammed into the upper atmosphere of the Earth and created a cascade of particles that finally tripped a detector in the Utah desert. Where it came from, no one knows for certain. The leading candidates include supermassive black holes at the centers of distant galaxies and the magnetic environments around the most violent objects in the cosmos. Whatever produced it, the universe is capable of accelerating individual atoms to energies that defy ordinary intuition. And those particles, in their countless trillions, fill the interstellar medium, day after day, year after year, in numbers and energies that no Earth-based laboratory can ever match. There is something quietly humbling about this. The interstellar medium is not just a place of slow, patient chemistry and ancient stellar deaths. It is also a place of constant, screaming particle motion. Every cubic centimeter of space between the stars is being threaded, at this very moment, by streams of high-energy particles racing through the dark. The cosmos is, in some sense, eternally alive with motion at the smallest scales, even where it seems most still at the largest. And then there are the worlds with no suns. For most of human history, planets and stars were inseparable in the imagination. A planet was, by definition, something that orbited a star. The very word planet in its ancient Greek root means wanderer, and referred originally to the bright objects that wandered against the fixed backdrop of stars in the night sky. The points of light we now know are Mercury, Venus, Mars, Jupiter, and Saturn. The idea of a planet without a star, drifting alone through interstellar space, was for thousands of years a strange and almost absurd thought. A planet without a sun, a world without warmth. A wanderer not just in the sky, but in the literal sense, drifting through the cold dark, untethered, alone. And yet, over the past 2 decades, astronomers have begun to discover that such worlds are not rare. They are not unusual. They may, in fact, be more common than ordinary stars. They are called rogue planets, or free-floating planets, or sometimes planetary mass objects when the precise classification is uncertain. They are bodies with masses similar to planets, sometimes as small as a few times the mass of Jupiter, sometimes only a few times the mass of Earth, but they do not orbit any star. They drift, alone, through the interstellar medium. They form in at least 2 known ways. Some are planets that were originally born in a normal planetary system around a young star, but were ejected from their system by gravitational interactions with their siblings, or by close encounters with passing stars, and now drift untethered. Others appear to have formed independently in the same way stars do, collapsing directly from a dense knot of cold molecular gas, but without ever accumulating enough mass to ignite nuclear fusion in their cores. They are not failed stars in the usual sense. They are something stranger. They are worlds that were never meant to orbit anything. The discoveries have been pouring in. In 2024, astronomers using the James Webb Space Telescope identified 6 likely rogue planets in a nearby star-forming region called NGC 1333 in the constellation Perseus, about 960 light-years from Earth. The masses of these objects ranged from roughly 5 to 10 times the mass of Jupiter. Several of them were found to have dusty disks of debris around them, the kind of disks that, around a normal star, would be the early stages of planet formation. These rogue worlds, in other words, are not just drifting passively. Some of them may have miniature systems of their own, with the potential to one day form moons or smaller companion bodies. In 2025, the European Southern Observatory's Very Large Telescope in Chile captured something even stranger. A free-floating planetary mass object roughly 620 light-years from Earth, drifting alone through the interstellar medium, was found to be actively consuming gas and dust from its surroundings at a rate of roughly 6 billion tons per second. 6 billion tons per second. A world without a sun, eating the dark around it, growing slowly larger across the long ages of its drift. Astronomers had never observed anything quite like it before. It suggests that rogue planets, far from being passive wanderers, can be active participants in the chemistry and matter cycling of the interstellar medium itself. And the most extraordinary part is this. Recent statistical estimates, based on a combination of telescope surveys, microlensing observations, and modeling, suggest that the Milky Way galaxy may contain more rogue planets than it contains ordinary stars. Trillions of free-floating worlds, drifting through the dark between every star you see. Some of them in the bubble we live in, some of them in the tunnels, some of them in the molecular clouds, worlds without suns, worlds without seasons, worlds whose surfaces, if they have any, are perpetually dark, perpetually cold, perpetually alone. There is something almost unbearable about that image if you let it settle. Imagine standing on the surface of a rogue planet. There is no sun in the sky. There is no warmth from any nearby star. The only light, if any, is the dim glow of distant stars scattered across the black, points of light so far away that they would not warm your skin, would not illuminate the ground, would barely register at all. The atmosphere, if there is one, may be frozen into a crust of ices. The oceans, if they exist, may lie buried beneath kilometers of solid frozen water, kept liquid only by the residual heat of the planet's own interior, or by tidal heating from a captured moon. There would be no day. There would be no night. There would only be the slow, eternal drift through the dark, at speeds we cannot easily perceive, on timescales that dwarf the entire history of life on Earth. And yet, even there, even in such places, the interstellar chemistry we discussed earlier is happening. The same prebiotic molecules, the same complex carbon rings, the same patient assembly. Some scientists have begun to ask, very seriously, whether the deep interiors of rogue planets, beneath their frozen surfaces, where residual heat keeps subterranean oceans liquid, might be capable of hosting some form of microbial life. Energy could come from radioactive decay in the planet's interior, from chemical reactions at the boundaries of icy crusts, from processes that have nothing to do with sunlight at all. We have no direct evidence of such life, of course. We may never have direct evidence, because rogue planets are exceedingly difficult to detect and almost impossible to reach. But the chemistry of the interstellar medium, the existence of rogue worlds, and the long, patient timescales involved all suggest that the question is not, on its face, absurd. It is a real scientific possibility, currently labeled as a hypothesis, and we may not resolve it for centuries to come. And then, beyond all of this, beyond the dust, beyond the gas, beyond the chemistry, beyond the magnetic fields, beyond the cosmic rays, beyond the bubble walls, beyond the tunnels, beyond the rogue worlds, there is one more presence in the dark between the stars. A presence that does not interact with light, a presence that does not interact with matter in any of the ordinary ways, a presence whose only fingerprint anywhere in the universe is gravitational, dark matter. Roughly 27% of all the mass and energy in the universe appears to be made of something that emits no light, absorbs no light, and reflects no light. Something that does not feel the electromagnetic force at all. Something that we cannot see directly, cannot photograph, cannot detect in any straightforward way. We know it is there because we can feel its gravity. We can see how it bends the light of distant galaxies as it passes through invisible clumps in space. We can see how it holds galaxies together, against rotational forces that should otherwise fling them apart. We can see how it shaped the formation of the largest structures in the universe, from the cosmic web of filaments and clusters down to the gentle pull on individual stars within galaxies. In our own galaxy, dark matter is everywhere. It is in a vast halo surrounding the visible disk of the Milky Way, extending far beyond the bright spiral arms. It is woven through the interstellar medium itself. In every cubic meter of space between the stars, including the cubic meter of space in your own room right now, there are dark matter particles, drifting through, passing through your body, passing through the floor, passing through the entire planet without interacting in any detectable way. They are not theoretical, they are physical, they have mass, they exert gravity, they make up more of the universe than all the visible stars and gas and dust combined. What dark matter actually is, at the level of fundamental physics, remains one of the great open questions of modern science. The leading candidates are exotic particles that do not appear in the standard model of physics, particles with names like axions, weakly interacting massive particles, sterile neutrinos. Searches for them are ongoing in deep underground laboratories around the world, in particle accelerators, in astrophysical observations. As of the most recent results, no candidate has been definitively confirmed. Recent experiments in 2025, including new analyses from the LZ dark matter detection experiment, continue to narrow the parameter space in which such particles could exist, but the mystery itself remains. What we can say, with confidence, is this. The interstellar medium that you have been imagining throughout this entire journey, the gas, the dust, the molecules, the plasma, the magnetic fields, the cosmic rays, represents only a small fraction of the total mass that fills the space between the stars. Most of the mass, by a wide margin, is dark matter. The visible interstellar medium, as rich and as strange and as beautiful as it is a thin overlay on a much larger, mostly invisible structure. The architecture of the galaxy itself, the way it holds together, the way it formed, the way it evolved is governed primarily by the gravitational pull of something we cannot see, cannot touch, and cannot fully understand. There is something deeply humbling about this. We have walked through layer after layer of the interstellar medium tonight. We have stripped away the assumption of emptiness and replaced it with chemistry. We have traced the bubble walls and the tunnels. We have followed the magnetic fields and the cosmic rays. We have found worlds without suns drifting between the stars. And at the end of all this, we have to acknowledge that even our most detailed picture of the interstellar medium is incomplete, because the dominant component of it, the substance that holds it all together and shapes its largest structures, is something we cannot directly perceive. The darkness between the stars is darker than we knew. And inside that darkness, woven through everything else, is yet another layer of mystery, waiting for the next generation of physicists to unfold. So here is something I want you to genuinely sit with before we move into the final part of our journey. Billions of rogue planets drift through the dark between every star we can see, worlds without suns. Worlds whose surfaces are perpetually frozen, whose skies are perpetually black, whose timekeeping has nothing to do with day or night. And there is at least the open scientific possibility that some of those worlds in their deep interiors beneath frozen oceans of ice might harbor something alive, something that has never seen a sun, never felt warmth from a star, never known anything other than the patient cold of interstellar drift. If that turned out to be true, if there really was life in the dark, on a world without a sun, somewhere in the bubble we live in, what would that mean to you personally? Would it make the universe feel more crowded and more alive? Or would it make the cold loneliness of those worlds feel even sharper? Drop your honest thought in the comments. I want to know how the image lands when you let yourself imagine it fully, because I think the way each of us responds to that picture says something quietly true about how we feel about our own place in the cosmos. And we are nearly at the end of our journey, nearly but not quite. Because everything we have discussed tonight, the 5 phases, the molecular clouds, the chemistry, the bubble, the tunnels, the fields, the rays, the rogue worlds, the dark matter, all of it has been about the interstellar medium of our own galaxy, the space between the stars of the Milky Way. But there is one more zoom outward to make, one more reframe to apply. Because beyond the boundary of our galaxy, in the staggering immensity that separates one galaxy from another, the so-called darkness of space continues and continues and continues. And what fills it, at the very largest scales of the universe, is stranger and more beautiful than even everything we have just described. Step now to the very edge of the Milky Way. Imagine, for a moment, that you have left our galaxy entirely. You are drifting, in your imagination, somewhere beyond the outer spiral arms, beyond the dim halo of ancient stars and dark matter that surrounds the visible disk. You look back. The Milky Way is now a vast, glowing pinwheel, hundreds of thousands of light years across, slowly turning against the deeper night. And ahead of you, in every direction, lies a darkness even more profound than anything we have described so far. The space between galaxies, the intergalactic medium. If the interstellar medium inside our galaxy is thin, the intergalactic medium is almost impossibly thinner. In the typical regions of intergalactic space, far from any galaxy, the density of matter drops to roughly 1 atom per cubic meter. 1 atom, in a volume equivalent to a small refrigerator. That is less than 1/1,000,000th of 1/1,000,000th of the density of the air you are breathing right now. By any measurement device on Earth, this is the closest thing to a true vacuum in the universe. And yet, even here, even in the spaces between galaxies, the darkness is not empty. Stretched across vast distances, in vast filamentary structures that span hundreds of millions of light years, is a substance that astronomers have only confirmed in the last 2 decades. It is called the warm-hot intergalactic medium, or the WIM. It is a thin, scorching plasma at temperatures between 100,000 and 10 million Kelvin, so hot that, in laboratory terms, it would vaporize any material instantly. So thin that, despite its tremendous temperature, it is almost impossible to detect. It does not emit visible light. It barely emits X-rays. It is one of the most elusive substances in modern astrophysics. And yet astronomers now estimate, based on the careful accounting of mass in the universe, that more than 40% of all ordinary matter, all the protons and neutrons and electrons that make up the visible cosmos, may be hidden in the WIM. Hidden in the long, thin filaments of plasma that stretch between galaxies, hidden in the structure of the cosmic web, hidden in plain sight, simply because it is too thin and too hot for us to easily see. And there is more. Filling every cubic meter of intergalactic space, threading through the WIM, threading through the dark matter, threading through the spaces between every galaxy and every cluster in the entire observable universe, is the faint glow of the cosmic microwave background. This is the oldest light in the cosmos. It was emitted roughly 380,000 years after the Big Bang, when the universe had cooled just enough for the first neutral atoms to form, releasing a sudden flood of photons that had been trapped in the dense plasma of the early universe. Those photons have been traveling almost undisturbed ever since. They fill space in every direction. They are everywhere. And because of the long expansion of the universe, they have been stretched from their original visible wavelengths into microwaves, glowing now at a temperature of just under 3 degrees above absolute zero. The darkness between the galaxies is not actually dark. It glows. It glows faintly, in microwaves, in every direction, all the time, with the residual light of the universe's own birth. If you could see microwaves with your eyes, you would never see a moment of true darkness in your life. The night sky would shine softly, uniformly in every direction, with the ancient afterglow of the cosmos itself. And around all of this, supporting all of this, sculpting all of this, is the cosmic web, the largest known structure in the universe. A vast, three-dimensional network of dark matter filaments, hundreds of millions of light-years long, with galaxy clusters anchored at their intersections like enormous beads on a tangled string. The cosmic web is what gives the universe its largest-scale shape. It is the scaffolding on which everything else hangs. The voids between the filaments are themselves enormous, sometimes 1 billion light-years across, regions of the universe in which the density of galaxies drops so low that one could travel for ages without encountering anything significant at all. And so here we are at the end of our journey with the picture finally laid out before us. Begin with the night sky. Begin with the darkness between the stars. Begin with the comfortable image you carried in your mind tonight before any of this. A black void, scattered with a few bright points of light. Now look at what that darkness actually contains. Gas in 5 different phases, ranging from temperatures near absolute zero to millions of degrees. Dust grains in their countless trillions, drifting through every region of the galaxy, catalyzing the slow assembly of complex organic molecules. More than 260 distinct chemical species, including alcohols, sugars, ring carbon compounds, and direct precursors to amino acids. Magnetic fields woven across light years, aligning dust and channeling particles. Cosmic rays screaming through every cubic centimeter at nearly the speed of light. A vast cavity, the local bubble, carved out by ancient stellar deaths, with our solar system sitting almost exactly in its center. Tunnels of hot plasma connecting our cavity to others, forming a hidden architecture of bubbles and corridors throughout the galaxy. Rogue planets in their countless trillions, drifting between every star, perhaps more numerous than the stars themselves. Dark matter, the dominant gravitational component, woven through everything. The faint glow of the cosmic microwave background, filling every direction. The filaments of the cosmic web, the largest structures in the known universe, anchoring it all. This is what fills the darkness between the stars. And so the original question, what exists in the vast darkness between the stars, begins to dissolve the moment you take it seriously, because there is no darkness, there is no emptiness, there is no void. What we call darkness is simply the limit of our own senses. What we call emptiness is simply matter and energy in their thinnest and most patient forms. What we call the space between the stars is, in truth, one of the most chemically active, structurally rich, ancient and ongoing environments in the entire universe. It is the ocean in which the stars themselves are merely the brightest condensations. The stars are not the main event of the cosmos. They are the visible peaks of a much larger structure, most of which is invisible to the naked eye, and almost all of which is older, vaster, and stranger than any of us were taught to imagine. There is one final reframe to offer, and it is perhaps the most personal of them all. The atoms in your body right now did not begin in your body. They did not begin on Earth. They did not begin in the solar system. The hydrogen in your water was forged in the first 3 minutes after the Big Bang, in a universe so young that no stars had ever existed. The carbon in your cells was made in the cores of dying stars billions of years ago and blasted into the interstellar medium by their final explosions. The oxygen you breathe was assembled in the same way. The nitrogen in your DNA, the iron in your blood, the calcium in your bones. Every one of these elements has a long history. Every one of them spent vast stretches of time drifting in the cold dark between the stars. Every one of them, at some point, was part of the interstellar medium we have been describing tonight. Every one of them is older than the sun, older than the earth, older than every story ever told. And in a very real sense, when you turn your gaze upward and look at the dark between the stars, you are looking at the place from which you came. You are looking at your own past. You are looking at the slow, patient, ancient environment that built the atoms that became the molecules that became the cells that became you. You are not separate from the interstellar medium. You are not an outsider looking in. You are a brief, conscious condensation of it, a small, warm, temporary expression of the same matter that drifts forever in the cold dark. There is something about that thought that, when it lands, changes everything. Because if the darkness between the stars is the place from which we came, then we are not strangers to the cosmos. We are not visitors. We are not isolated specks of consciousness in an alien void. We are the cosmos becoming briefly, locally, momentarily aware of itself. We are the interstellar medium thinking about itself. We are, in some quiet and almost unbearable way, the way the universe knows that it exists. The original question dissolves, not because it has been answered, but because it has been transformed. There is no vast darkness between the stars. There is only matter and energy at every scale, from the smallest atom to the largest filament of the cosmic web. There is only one continuous ocean in which we are a single brief wave, listening to a voice on a small wet planet, in a hollow cavity in a spiral arm, somewhere in the middle of all of it. Let your breathing slow now. Let your eyes close if they have not already. Let the picture rest in your mind. The stars are not isolated points of light scattered across a black void. They are bright condensations on a vast, slow, ancient ocean. The darkness between them is not empty. The darkness is full. The darkness is chemistry, and plasma and dust, and magnetism and ancient light and invisible mass, and worlds without suns and patient molecules, and the gentle drift of matter older than the earth. The darkness is the place from which we came, and the place to which, eventually, we will return. Every atom in your body will, in time, be released back into it. The interstellar medium will continue, long after the earth is gone, long after the sun has burned out, long after every star you can see tonight has cooled into silence. The cycle continues. The slow chemistry continues. The patient assembly of new worlds, new stars, new conscious beings somewhere on some quiet world, on the edge of some other bubble in some other arm of some other galaxy, continues. And somewhere, on a small wet planet on the third orbit around an ordinary star, in a hollow cavity carved by ancient violence, a voice is speaking quietly into the night, and someone is listening, and for a brief moment the universe is awake to its own immensity. That moment is now. That listener is you. Before we close, if this kind of slow, deep exploration of the cosmos brings you peace, or wonder, or something quieter than either of those, a final like or subscribe really does help the channel grow. It is a small gesture for you, and it makes all the difference for the work that goes into bringing you nights like this one. Thank you for being here. Thank you for staying. Thank you for letting your mind wander out into the dark with me. And now, as your breathing slows and as the room around you settles into quiet, remember this. The darkness above you is not empty. It never was. It is full of ancient light and patient chemistry and the slow drift of the matter that became you. You are not separate from it. You are a brief condensation of it. And tonight, beneath the soft glow of stars that are older than your bones, beneath the gentle pull of forces that have been at work since long before there was an earth to hold them, you are exactly where you belong. Sleep well beneath the slow, ancient ocean of the cosmos. Rest gently beneath the light of stars that were already old when the first humans looked up. And remember that the darkness between them was never empty, and neither in the end are you. Good night.